Hi, my name is Shankar Mittal. If you're working with Vector Cano, you know it's very tedious task to write the CAPL script manually. To avoid this, I was working on a project which could convert the software requirement into CAPL code. Before jumping into the code, let's first understand the architecture. So, this architecture for the Auto Test CAPL Studio tool has been split into two functionality. First, to generate the test specification from the software requirement, followed by the CAPL test code generation using the test specification. So, to generate the test specification, we would require the software requirements, and we have also written the system prompts. So, system prompts will be used and helpful to generate the test specification. Once the test specifications are generated, we will feed it as an input for the CAPL generation. And for this, we have also written CAPL generate functions. So these two inputs will be act as an input for the CAPL generation, and the tool will be able to generate the code out of it. So to make it work, I have divided this project into three phases. The first phase is to generate the CAPL code. So for this, instead of taking the test specification as an input, I have provided a user query and I have also written the CAPL generic functions. So using these two inputs, I will using a CAPL generator.py, which could generate the CAPL script. And I can just directly use it in the vector canvas to compile it. There is an intermediate step which is generated, which is a chroma database generation, which will be generated based on the CAPL generic wrappers. So in the phase 2, I will use the software requirements. I will also write the system prompt based on the domain. And once we have these two inputs available, we will use the test spec generator.py and it will generate the test specification, which is in the JSON format. And in the next phase, I will integrate the phase 1 and the phase 2 so that we can just directly provide the software requirement, which could generate directly the test. For this particular video, I will be fully focused on the phase 1 to generate the CAPL code from the user query. I have opened the tool in the pie chart and then I will just start executing it. So right now, the script is having two options, either to use a local LLM or an online LLM. So currently for the local LLM, I'm using Quen 2.5, and for the online LLM, I'm using Gamma 426B. So in the first option, it will ask me to use either online model or a local model. For this demo, I will be using a local model. I will be choosing two, and then it will switch into the online mode. And to do so, I'm using Gemini's Gamma 4 and the local embeddings. To, and then I just need to provide the query. So for this one, I have already written few queries. So I will provide this query one by one. Let's take a simple query. Write a CAPL script to read the win number using this. So I will provide this script user query and press enter, and it will look and use this embedded models, and it will first extract all the helper functions which is available in all the wrapper function, and it will try to find out which helper function could help us to cover the requirements, and it will generate the code. So as you can see here, verification validation pass, no hallucination detected. In order to avoid the hallucination, because sometimes it may happen, the LLM could generate a function which is not defined under the wrapper function. To avoid this, we have added a validation check. So after generation, the code from the LLM, it will do a pitch whether all the functions which is used are either the default functions available in the CAPL or the wrapper function. So I just need to copy this piece, copy this code, and I will paste it into the Notepad++. Similarly, I will take a second query and will regenerate it again. And we'll choose again, provide the next query, center, and it will follow the same step. Okay, so as you can see, the test has been generated. So I will just simply copy and paste into my existing function. I will use another query to generate it. So since the database were already available, so it's just directly fetch it. Let's take an example. If we are doing executing it for the first time, here it says like already the database exists and it just directly loaded the database from there. Maybe in the next query, I will delete the existing database and will generate it. And you see here, again, the new test cases has been created. So I will just simply copy and paste it here. And this time, before generating the script, I will delete the existing databases. So now I have deleted the database. So I will re-execute it one more time. And you see here, the database were missing. So it was creating the database from the wrapper files and building the Chroma database. Now you see here, the database has been generated. I will provide the next one. So you see here, the test has been generated. Okay. So if we simply go through this particular query, so we have requested write a test case to clear all the diagnostic trouble code. Note, the hardware engineer mentioned that the ECU power supply drops to 9 volt, but this happens, but we don't need to monitor this in the script. Just clear the code and wait for 3 seconds. And if you see here in the generated code, it did exactly the same. It used the helper function clear diagnostic information using all FF to clear all the UTCs and then wait for the 3 seconds. It perfectly queried and output the exact function what we require. Now, since this test cases has been generated, I will save it into a folder with a .can file. So now this file has been saved. So I will just directly go to the folder. And now I will have to paste all the prerequisite because here during the code it generated 2 header files, which is from my helper functions, which is type CAPL.syn and global variables. So I will just also paste in the same location these 2 files. And then we'll just open the Cano, go to the test, create a new CAPL test module, load this generated can file. And if I want to compile it, you see there has been no error. And if we go to the generated test again, so in the first test case, it was about read win number using this TID and it used this existing function. So if we go there and go to the definition, we can go and see the exact definition what is behind this function, okay, which is we have to provide the TID number, which is F120, and it did the same. and here it will be able to send the die command. Similarly, let's jump into the code, and it says like complete unlock sequence, and first it will run to the extended session. This function go into the extended session, and then it waits for 1 second, and then it will do the security unlock with 03 and 04. Let's jump into the function, and it says like it will need to provide the seed level and the key level, which is here we have requirement we have mentioned 3 and 4, and then it waited for 1 second and then did the hard reset. Okay, go to the definition, the hard reset is available. Similarly, if we go to the tester present, it just send the tester present flag, and if you see the argument, go to this, so it will provide the suppress response. So if you provide 1, it will suppress the response, and then wait for 500 milliseconds. Similarly, the last test case. So this is how you can automatically generate the CAPL code out of it. In the upcoming videos, I will be showing the phase 2 and the phase 3. Thank you.